So here's the note well. Please let us know if you have any questions.
Make sure you read it before you speak.
So administrative tasks, we have 2 note takers and a Jabber scribe, so thank you. If you want to follow along with the notes, the Etherpad link is on this slide. You're more than welcome to help out in addition to our 2 note takers. Here's our agenda for today. Any agenda bashing? All right. So working group status. We have 2 drafts that are currently in working group last call. I think
technically the working group last call is completed once. But
we've done at least one working group last call. So I think we're going to want to have some discussion during the draft updates about next step on those 2 documents. We also have the suit manifest, which is progressing rather well. There's been some recent updates to that, and so I know I'm personally interested in where the next steps are there too. Milestones, we're doing okay on our milestones. We recently revised them. We're expecting to submit 3 documents to the IESG, or 2 documents to the IESG this month. The architecture and information model. So we'll need to talk about how we can accomplish that, and then we're expecting at the next IETF, or by the next IETF, to be able to submit the suit manifest to the IESG as well. Or if TEEP doesn't continue to give us issues.
Yeah.
I think that's the... So I think with that, we're going to switch to the hackathon. Hannes?
So, okay, this hackathon announcement. As you can see, if you have been following the mailing list and you've seen that we posted a few mails with a doodle poll finding a date for a hackathon, and we decided not to do it at this meeting, but actually do it separately. So there's it's always a question of distraction and so on. This is a very busy meeting, as you know, or all IETF meetings are very busy. And we've been quite successful in doing the hackathon last time in Berlin. So we thought that we should do that again with the help of Matthias. I don't see him in the room right now, or is he? Okay. But in any case, he set up a website, which I think by now includes a registration link. So the idea is that we have a 3-day event, 3 full days. The first day with a tutorial, and that tutorial is focused on giving you some or enough information, hands-on information, so you can then actually be productive at the hackathon. So this is not a 1-day slideshow, but it's the whole thing is very hands-on oriented, and will cover the work from these 3 groups, namely Suit, Deep, and Rats, because they are all interrelated. And we haven't worked out the tutorial day, the agenda yet, but that will happen in the next 2 weeks. I've had a chance to talk to a few folks here and find some volunteers to present. And you will have to register. It will be free of charge for you. But I need Matthias and I need the registration information for 2 reasons. First, of course, the logistics, catering, etc. For the host, but also because I'm ordering hardware so that we actually have something to play with. And needless to say that I need to know like what hardware to order, because there's obviously some slight differences between the different groups. And for the Rats group, the current, so it hasn't been fully finalized yet, the hardware selection, but for the Rats group, we are thinking about using one of the latest NXP boards on supporting ARM v8m, so we can actually test out these the results from the RATS attestation work. For deep, Emmanuel suggested a board also from NXP, one that is an earlier generation using Bluetooth Low Energy, using ARM v7m. And for the software updates not for the deep work, we might be, or Dave suggested that we actually use virtual machines, but in addition, I want to also order either the board that he's recommended on the list today, if you've been to the earlier deep meeting, or the STM32 MP1 board that I've been using recently. So there would be a mixture of different devices out there, and depending on who registers for what, will make those boards available. There will be a little bit of effort for you, for those who participate up front, because we need to make sure that we have the software, the development environment set up appropriately, so that we don't waste time fixing those issues during the hackathon and also the tutorial. So I would encourage you to participate, specifically if you want to get a better understanding of the technology, because I think that's the only way to get there. And I think this is a unique opportunity, because you will hear from some great speakers during the tutorial, and then hang around in a nice environment in Berlin to work on these protocols. And we'll make code available as much as we can beforehand, so that we can start with a good baseline and then look at some more interesting advanced use cases at the hackathon. The date, you see it on the slide, mid of February, based on the result from the Doodle Bowl. And yeah, we also would like to thank the chairs of the 3 groups for their support. And yeah, hope to see you guys there.
Thank you. So next up we have the suit architecture. There you go. Back again.
Cool. Okay, that's a short presentation. Short because we have been running the working group last call since I think February or so, or April. So it's a little longer working group last call than usual. But there have been a couple of updates in between based on the feedback. And this is just a sort of a brief history or status. Version 5 included some extra text on bootloaders because there was the request, and with version 6 we added the deep related information because of the decision from the working group to harmonize the work between those 2 groups. So that has been done. And then more recently, Kathleen has posted a review, a more detailed review, and which led to version 7, which is the most recent version you have in the repository. There have been various changes throughout the document, but I specifically wanted to point out one change that concerned the section on state-of-the-art security mechanisms, where I went into a little bit more detail on what the different state-of-the-art security mechanisms are, because Kathleen was specifically commenting on those and questioning the value and on sort of the meaning of what we have written there. And so I have specifically pointed out the authentication, integrity protection, confidentiality protection of the firmware image and potentially the manifest as well. And then talked a little bit more about the hash-based signatures, and they are used with sort of like the potential danger of quantum computers, and the fact that you have a certain amount of unchangeable code in a bootloader. And so if you nail down specifically cryptographic algorithms, then devices that have a longer lifetime obviously will then be at the disadvantage when suddenly these quantum computers and their when existing security mechanisms, classical security mechanisms, suddenly don't work anymore. So that's why I made this a little bit more explicit. And also, we talked about sort of the mandatory to implement security algorithms, and I tried to be a little bit more generic here rather than listing the specific algorithms, because probably the architecture isn't the right place to make those recommendations anyway, which is in line with what we did also 2 hours ago or so in the deep architecture.
So in the bottom paragraph on the screen, it says has to be defined. Is the intent that that's going to say is defined in the suit manifest, or what is the goal for that?
Yeah, that would maybe the wording could be better, but has to be defined elsewhere, not in this document, not in the architecture document.
Is it in the suit manifest document right now? And if not, then where is it, or is this something that the working group still needs to do?
Good question. That's a good question. I have to check.
Okay.
I have to check.
I don't know this. Brendan. Oh, here he comes. Thank you.
Okay.
He's coming to answer. You're up, Brendan.
It's not currently defined in the suit manifest.
Do you think that it should be?
I can't see somewhere that would be better.
Noted. The suit manifest has not gone through working group last call yet, and so we
Yes,
will leave
so-
that as an action item for the suit manifest, and the architecture document can then just say referencing the suit manifest document.
I will file an issue.
Okay, great. Thank you.
Okay, thank you.
Okay. Good. The audio at least works for Brendan this time.
Dave Waltermeyer, can you go back one slide?
Oh, sure.
So, Dave Waltermeyer, have you considered 128 bits of security in this case? Because software updates can be long-lived information. A lot of the existing European and NIST guidance indicates 128 bits. For information that has a lifespan of 10 years or more. That's also reflected in RFC 7925.
Good point. I probably should update that and point to those other guidelines. You're right.
So
I will do that.
should that be, because you'd start off on us by saying maybe this shouldn't be in the architecture document. Do you want to move the
Right.
key length discussion of the suit
Yeah.
manifest and just reference it here?
Yeah, I will.
Okay.
I guess I better do that.
Okay.
Okay. Good idea. So the other question, which I think was a little bit more generic, which I wasn't able to answer in form of text in the document yet, or at all, is the document currently, from the history of the group, focused very much on low-end IoT devices. And Kathleen was saying, like, is there anything in there that prevents us from using this on other IoT devices that are bigger? And like a classical Linux-based device, embedded device, rather than something that already has, like a laptop, has a perfectly fine software update mechanism, so we don't need to work on that. But one could imagine higher-end IoT devices that use classical Linux, you maybe use some of the stuff we work on in the deep working group. And so you may actually use the same software update mechanism there that we develop here. And is there anything in the document that we should be doing to explicitly call out those cases as well? And yeah, and it's really a question for the working group, to rather than me unilaterally suddenly expanding the scope of the work here.
So I think maybe question for Brendan, because I thought that there was a statement that he had already added, but maybe it's in the suit manifest document. There was some statement about, nothing in this prevents its use in larger scenarios, some paraphrasing of that. But I don't remember which document they got put into, but that came up when Brendan was presenting to the TEEP working group. And I think some statement got added, which was maybe in an interim early this year, and then he put in some statement after that, I thought, but I don't remember which document it was.
But there's still, in some sense, there's a little bit of, we can put that statement in there or double check whether it's in there, but the other question is, of course, to go and look into details, and in some examples, like do we really cover everything that needs to be done, or are we talking about extensions here or something else? Maybe we missed something because so far the focus was on something else. And even in a deep case, while the devices maybe or are larger and different to what is the primary focus here so far, there we have been talking about updating trusted applications, and what Kathleen was talking about is updating everything else as well, including the rich operating system like a Linux, updating the Linux, updating the monitor code, updating the RE OS, and so on and so on.
Brendan, go ahead.
Hi, yeah, the update that I put in was definitely in the manifest document. It said essentially that while it's informed by firmware update use cases, there's nothing that prevents using it anywhere else. And in fact, I don't know how useful this is, but I have seen a few instances of people using an update system very similar to this for updating Linux devices, and even seen some discussion about using it to update Windows devices with whole system images.
Okay.
Thank you, Ben. Yeah, the question is like, do we really need to do something here on this document, or can we take this and move forward and sort of progress it to the ISG and then get it published?
I was just going to add, our charter doesn't preclude a solution that works for higher-end devices either. We just wanted to make sure that the solution we did design would work for Class 2 devices.
Right. Yep. So if we have text in the architecture document that says that it is intended to address a wide range of things, scaling all the way down to Class 2 devices, that implies it can also scale up.
Yeah, I will double check whether that's indeed sort of crystal clear. It may not. It may not be entirely there yet. So I will do that.
Yeah,
and
I remember being happy with the phrase that Brendan mentioned, but he said that was just now.
Yeah, that was in the
manifest.
Yeah.
So if we have some,
so maybe I need to copy something over, and that should address all the review comments that Kathleen raised. I haven't seen her so far yet, so she may actually not be here. I have no idea.
She's not here.
Okay.
Michael Richardson, I feel like we've been through this discussion 12 times. Michael Richardson.
Which discussion?
This discussion about the upper bound of it. I feel like we did this in the chartering even. So I just don't know why we really. I wasn't going to stand up because what was the point? We've done this already, but why are we still talking at this point? So do we really? Maybe the issue is that as the document goes, Kathleen's issue is the document goes to other parts of her and other companies. They're like, oh, but this is only for IoT, right? Blah 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 blah, whatever that means. And so we actually just have to kind of beat them over the head. Is that really what it is? Because I'm like, well, I totally expect someone to upgrade the BMC of any kind of a server system using Suit, right? The base microcontroller. Like I totally expect that. I think that's totally in scope. But maybe the guys over there thinking, that build 3U servers just hasn't occurred to them that their BMC is an IoT device because it turns power on and off, right?
Well, maybe it's a purely perception issue, and but I had to, as the editor of the document, I had to somehow have to address those reviews, and so I'm trying to figure out what can I do differently or better to
maybe just need
address
more
those.
examples. Maybe just need more examples. That's all. This is explicitly included. For instance, blah blah blah, and we should just ask for 10 points of weird things that people thought about that would be appropriate for Suit that no one wouldn't otherwise think about. I mean,
well, why not?
Yeah.
Okay. And then hopefully we are done with that.
Is it worth asking if folks feel that it's ready to go?
I don't know. I think that's our call because we've asked for the last call comments and we've gotten all the comments.
How do we stick a pin in this?
Okay. ask if there's any more issues coming. If not, then we plan to take the update and expand it, yeah.
Are there anyone in the room that have any additional issues for this document? Because if not, after we address this one question, our plan is to send it forward to the ISG.
I see no objections. Okay.
So we should confirm that on the
I
list.
see an AD with a thumbs up, so it sounds like a good process. Yeah.
All right, sounds good. Hannes, when can we expect an update?
I'm looking at the text from the manifest right now and try to include some examples, so it should be much later.
Are you saying by the end of the meeting?
Our milestone just says by November, so.
Yeah, he's working
I
on it
know.
right now. All right, yeah, soon.
I did update last time the draft right at the end.
That's
You've
true.
set a precedent.
That's true, that's true.
Yeah, exactly.
Now the expectations are there.
Okay, yeah, as soon as you can get that to us, thanks. All right, so next we have information model. Brendan, you want to step in the queue? All right, Brendan.
All right, next slide, please. So the last call has been going on for a while, but I think that maybe the middle of August, not many people noticed that it has started. We've had a fair bit of review already. I
just updated
just got a review yesterday, which I'll come to in a little bit. So I think that we are progressing pretty well here. If anyone has any further comments, now's the time. Next slide, please.
Overdue.
So one of the big changes was that I've added in a few new threats and security requirements that justify the architecture's mention of an end-to-end security model. Previously, that hadn't actually been mentioned in the information model. Next slide, please. So there are a few different threats that I added in to cover that. So first, there was the interception of data between the update service and the device. And then key exposure threats, specifically extraction of signing keys from some form of signing service. That would be if it were hosted or potentially if it is a non-hosted service. Then as well, the possibility of a manifest being modified in some way between the author attempting to create a manifest and it actually arriving and being signed by whatever signing service, be that local or remote. Next, please. Then the requirements for mitigating those threats. So they proceed kind of naturally there. Secure channels are necessary to protect status reports. Key protection is necessary to prevent key extraction. Manifest checking would be an important part of validating manifests to make sure that they haven't been modified in some unexpected way. And of course, making sure that a trusted environment is used for constructing manifests. Next slide, please. So there are still some more reviews coming along. There was one that, as I said, that just came in yesterday, and evidently I've missed a whole series of uses of mandatory rather than required. I added in some examples of UUIDs, specifically the white labeling use case where one vendor sells the products of another vendor under their own branding. And one of the features that had previously been in the information model was using channel security for authenticating updates, specifically where the manifest contained only a URI. The intent there had been that you didn't need additional authentication steps to be able to just replace the URI of a manifest, so that a a gateway, for example, would be able to override where a device would look for its update or look for a further manifest. But what was pointed out to me was that this would allow an attacker that is able to compromise the channel or the communication partner to then get all of the devices that it communicates with to make arbitrary requests over the network. So this seems like we should probably plug that hole, and so I've explicitly disallowed that in the information model now. And I'd be very interested in the feedback from the working group on that particular change. One other minor change in the information model as a result of the reviews that I've just recently received was to define a maximum size for the integrated payload. Now, the maximum size that I've defined is the whole thing has to fit in memory, which I think is a pretty reasonable approach to saying how big it can be. Now, we might need to be more specific than that, and again, I'd be interested in the working group's feedback on whether we should be defining a numeric maximum size or leaving it as just the whole thing has to fit in RAM. Next slide, please. So we've asked for further reviews, and we want to make sure that the document is complete. And I think that it's in quite good shape now. So I'd like to know if there's any more feedback. Next, please. Or is that it? I think that's
the last slide.
That's the last slide. All right. So very quick update there.
So what should we do on this one?
Ask if there's more feedback coming.
Does anybody have any issues with
Yeah.
resolutions and stuff like that?
Yeah.
Does anyone have any issues with the current draft?
Well,
Or even
including these, which are,
including these proposed updates.
see, the several proposed changes in GitHub are the ones not in the posted copy yet. Those are the ones that would be in Brennan's next posted copy.
That's correct, yes.
Hi, this is Henk at the mic. Henk. I'm giving up on this. Hi. This is a manifest-related question. Is that okay right at the moment?
The next presentation after this is the one for the manifest.
Then I wait for the manifest. Okay. Yeah.
It's
Okay. Let's
information.
wait for the manifest. It's somewhat co-connected, but okay.
If it's about requirements for the manifest, it goes here. If it's about how the requirements are met, it's about the other one.
Okay. Yeah. 50-50.
Like Emmanuel.
So tell Brendan.
Brendan, I'll have to knock you out of queue.
Please get back in. Yeah.
Emmanuel, go ahead.
Hi, Emmanuel here. Do you hear me fine?
We do.
Okay. Yeah, just bouncing back on a comment from Brendan on whether we have to put in numerical limits to the size of payloads and things like that. I think this might be a little bit difficult, like on our end, for example, with our riot implementation, we really tried to push down the RAM requirements quite a bit, such that payload actually definitely does not fit in RAM. So we use things like co-op write and things like that to bring down the minimum RAM requirements. So I think we have to be careful here not to put any strain on the RAM requirements. We may, however, try to look at flash requirements. I mean, if you can't like put there somewhere in the memory and not in the RAM, this whole payload, then you have a problem. But else, yeah, that was it.
Brendan, you're back. You want to respond to that, or?
Yeah, hi Emmanuel. Sorry, I think I must have not been quite clear enough. This is specifically for the integrated payloads. So this would be if you're passing something very small along, like, I don't know, maybe an encrypted key that's being delivered to a device. So not the whole payload of a firmware update, but instead just a small payload that a device is using for some other purpose.
And clarifying question, Brendan, please stay in queue. Since we just had the discussion about whether this could scale up to larger class devices than class 2, are you thinking that the maximum size would be independent of device size? Are you thinking that the maximum size would be for the class 2 devices or something else?
Well, this is why it's currently defined as the whole manifest, whatever that means, integrated payload or no integrated payload, has to fit in memory. And I think that that makes it fairly straightforward in that respect.
Right, but the question is, in whose...
Like numbers.
Okay, sorry, let me rephrase the question. If it has to fit in the device's memory, who's expected to know how big the device's memory is and what that limit is? Because is the manifest author expected to know that? Because maybe the device is a tiny IoT device, maybe it's an 8 gig memory device. Is the manifest author expected to know that, or is the spec pick some number, or what? What is your proposal?
Yeah, that's exactly the problem, and that's why I'm asking for feedback. So my inclination would be to say one of two things. Either the maximum size should be defined as, enough to fit a key or a key wrapped key, or it should be defined as it's up to the implementer to know exactly what fits. I don't really like it's up to the implementer to know what fits, but at the same time, picking a number out of the air might break some use cases. So I'm a bit confused as to where we should handle that.
Okay, so if I understand right, you don't have a proposal and you're asking the working group for advice between the different options here. Is that correct?
Yeah, so it's a binary choice here. Either we define a number or we say it's up to the implementer to know. And I prefer having a number, but I recognize that having a number is going to break some use cases. So I'm not sure exactly where we go on that one.
How do we deal with multi-party update cases where there are multiple implementers and there might not be pre-knowledge of the size? Because our architecture allows for those kinds of cases.
Memory.
The size of memory, right.
Okay, so the other possibility here is that we look at capability reporting. We've talked about capability reporting a bit in the manifest draft, and maybe that's something that we need to address as a working group. So capability reports would possibly handle this situation where you're able to get information back from the device at the time of manifest creation and look at how big of a manifest will this device accept, and then that makes it sort of academic.
Any other working group participants have an opinion on this question?
This is Hannes. In the deep working group, Hannes, and in the deep working group, if when I am going to talk about the protocol, there is actually a capability discovery mechanism to do that. But I understand the difficulty, because obviously, like, the manifest needs to fit somewhere in memory so that you can then verify the signature. Because otherwise, of course, the manifest will in general be very small, but so that is typically not an issue, as Manuel pointed out. But one can imagine cases where you, specifically with the use of public key crypto, you may include not just the signature, but also a key and so on and so on. So it could get larger, of course. And so I don't have a specific recommendations on what number to put in there. So I would prefer to actually to leave it open, but to point out what the problem is. I think you can't do much more than that.
So this is Dave Thaler. It's occurring to me there's a slight analogy with something like a reassembly buffer in protocols, where, for example, what IPv6 did is they said you must be capable of reassembling something of at least this size for some number, like 1280 bytes, or pick a number, whatever. But you're allowed to pick something larger than that. And so that means if you are authoring something, if you want it to be perfectly interoperable, you make sure it's no larger than that minimum. If you have specific knowledge of the other end, you could go larger than that and still be compliant. So that would be a possible approach that we could take. I don't know if that's the right thing or not, but that would be a way that actually supports both sides and says it's not a maximum size, but it's the maximum size at which interoperability is guaranteed without knowledge of the other ends. Right.
So that's a third option.
Right. So I think there's 3 options now that we've talked about.
Any comments on that third option?
Yeah, it doesn't look like there's a lot of energy around picking one, so.
I'm not sure we'll get a lot of energy.
Right. After the discussion, Brendan, do you have any preference from what you've heard out of the discussion from the working group so far?
I'm going to have to think through that a bit more, I'm afraid.
Okay.
I like the suggestion that Dave has proposed, but at the same time, I think that the danger in that is that you end up with a whole bunch of devices that implement explicitly the minimum rather than what they need.
Okay. So what should we do?
So I'm going to have to think through it a bit more. I don't think I can make a recommendation just yet. So I'll make a recommendation on the list once I've had some time to think through it a bit more.
Okay.
Can we do it in this order then?
Here, go ahead, Russ.
Since we're trying to get this sorted by the end of the month, can we do it in this order? Make the recommendation of the list, discuss that, update the doc, confirm the last call. Issue is resolved.
Yeah, that sounds good to me.
Okay, good.
So just working back for the rest of the month, we've got what 12 days, 11 days. So how much time do you actually need to think through this to post a solution?
Well, I'm hoping to make a recommendation, sort of within the next, 2 days. 2 days. So not long. Not in the middle of the meeting. That's all.
That's fair.
Right. So I mean, thinking through that. So if you post something to the list in a couple of days, maybe we post an updated draft next week. After we've had some conversation about the solution, and then we could have a couple weeks of last call review before we close out the document. That would put us a week into December, but that's not too bad. Would something like that be doable on your end?
So, yeah.
Hi, this is Mohit. I'm just wondering if you put a maximum limit, what would that be? Just to get an idea. Mohit.
So, I was looking here at defining the maximum size of an integrated payload rather than the maximum size of the manifest itself. It might be more useful to define a maximum size of a manifest, but that can be highly dependent on the use case. It's not a fixed size format. And in that respect, maybe that's one of the things that I need to work through in the next couple of days. What makes sense for maximum sizes in that respect? When we look at things like embedding into bootloaders, keeping it really small is very important. So getting the size of the manifest down for that use case is something that we should perhaps be defining the maximum size for the manifest in each use case. I mean, if you look through the examples that are in the manifest document already, then there's a few examples of what sizes could be. I think that it's something that we should probably, take feedback on as much as we can at this point. But I think it's easier to define a maximum size of a payload than it is of a whole manifest.
Right. So in the payload, like you would typically have keys, signatures. So just take like what is maybe not completely insane, but somewhat nonsensical, and then define. So I don't know, 4096-bit RSA keys, and then taking some signatures and then defining the maximum limit.
Yeah, and I mean the other thing that might show up there is configuration. So you could imagine fairly easily a bit of CBOR being delivered in an integrated payload, because it makes more sense to do that than to have a completely separate transfer to handle that relatively small chunk of data. And that's where things get a little bit more complicated, because what's a sane size of CBOR to deliver to a device in the manifest rather than outside of the manifest? So that's essentially the use case that I'm trying to work through, is if I'm delivering something reasonably arbitrary, like a configuration blob, in the manifest, how big should that be? Well, that's highly dependent on exactly what's being delivered, and that's why I'm sort of trying to work through this before making a direct recommendation. As I said, this is something that only came up in the last 24 hours for me, so I haven't really had time to work through it yet.
So after listening to this, I think I've changed my mind. Maybe we can document all these considerations and not give any minimum or maximum. I think for implementers, like even if they're pushing updates, they probably do some kind of testing before they start, push. Any sensible developer would do some kind of testing before they start pushing updates. So we document all this and then don't give any like min or max.
Thanks for your feedback.
Brennan, on your slide, you say several proposed changes in GitHub define maximum size. In GitHub, is there any specific value proposed in GitHub right now, or not?
No, there isn't
Okay.
at the moment.
Okay.
What it says right now is that it has to fit in RAM.
Okay.
And the reasoning for it has to fit in RAM, which isn't in GitHub, I should probably put that in, is that we need to be able to verify the signature across the manifest in one go.
Yeah.
Because otherwise that leads to a time of check, time of use vulnerability.
Okay, so in the interest of facilitating consensus, since we had one person actually express an opinion rather than saying need to think about it, then is there anybody that would have an objection should we actually choose to go with the not defining a strict number in here? Is there anybody that would actually object to that? Just trying to facilitate some advice for consensus. So I heard one person said that makes sense. So okay, so far as chairs, we're hearing general support by that, but since it's only been 24 hours and hasn't been discussed on the list, we need to confirm that. But if that helps you, Brendan, know what to think about.
Well, for me, that's the status quo. That's where it already is.
Okay.
So I'm reasonably happy with that.
Yeah, but what was implicit in that was that we would define, or that you would define some considerations relative.
Right.
Yeah, and it's clear that those considerations do need to be defined.
Okay. Sounds good.
Yep. Great. Thank you.
We have a way forward.
So next up we have, I think, the manifest. So Brendan, if you would stay in queue. Please go ahead.
All right. Next slide. So we had draft 5 approved for adoption about 4 months ago. Now, we incorrectly submitted version 4. Sorry about that. So that was immediately updated to, or not immediately, shortly after updated to version 1, which was the correct version. Version 2 was announced on the list recently and contains some relatively minor changes, mostly in terms of text, not encoding. Next slide, please. So primarily what was added was an interpreter behavior section, which defined an abstract machine. Now, that is mostly informational. It's essentially a mechanism to help implementers to understand how to construct the interpreter. The other thing that this will do is make it a little bit easier for us to do some testing. So we also added templates for constructing manifests and the text field enums, which have been missing for a while. Next slide, please. So for interpreter behavior, it goes through a number of steps. First, there's a setup phase, so that's what to do before invoking the interpreter. It includes things like clearing out any parameters or making sure that you're loading the most recent valid manifest. The next thing is required checks, and that's things that the interpreter has to do. So, for example, that would include validating signatures, that would include making sure that there is a vendor ID and class ID check that's been done. Then there are commands that have to appear in the manifest, and as I said, could include the vendor ID and class ID. Some of the other checks that might show up are things like making sure that the right sections of the dependencies have been executed. Then it goes through to explain how an interpreter should behave. And the intent here is that two different interpreters should interpret each manifest in the same way. And that gives us the basis for enabling consistent behavior across devices and across implementations, which will be really important for interoperability later on. And then we define an interpreter abstract machine. Now this is a relatively lightweight definition. It's just a series of statements of exactly what each different element in the manifest commands should do. And the idea here is that we should be able to build very fine-grained test vectors for interpreters and interpreter validation suites. So that'll make it hopefully a lot easier for people to be confident that their manifest interpreter is behaving according to the spec. Next, please. I've also gone through and added some sections defining what serialized processing would do as an interpreter. So that's where each component ID is processed in sequence, and that's out of sequence with the normal manifest flow. The idea here is that for extremely RAM-constrained devices, it's still possible to handle multiple components. And then for large devices where parallel processing is relevant, how you process commands in a parallel processing interpreter. And that would also allow out-of-order processing of certain commands. Then I've added a section on how dependencies are handled in the interpreter behavior section as well. Next slide, please. So then I've added a new section on creating manifests, and this includes one mention of including source material in the text section of the manifest. Now this might be interesting for intermediate systems, since the author can provide a document that is in a more conventional form, and that would allow intermediate systems to handle it simply. But then at the same time, that can be pruned with the severable section that is with the text severable section, so that that's never actually delivered to the end node. So we also added templates. So the idea there is that it gives the authors of tooling some help on exactly what different use cases should look like once they are built into a manifest. And then there's a few use case templates that explain exactly which commands you would need to accomplish different tasks. Next slide, please. So I've added in some text field definitions. Those have been noticeably missing from previous versions of the draft. So there's a few. There's the ones you would expect here. Vendor domain and model info are the inputs to the UUID 5. function which might be useful in some cases. Then the JSON source and YAML source are two examples of an input file that you might use to create a manifest in the first place, and then that input file can be included in the text fields as well. Next, please. So for next steps, we think that the draft is in a pretty good state. There's been a few editorial PRs, most of which have been merged. We're wondering if there's a better name that we could come up with than just suit manifest. Because right now, if you don't know what you're looking for, you probably won't find it. For technical proposals for version 3, we have a few, which I'll get into in a moment. So we want to look at the use of run sequence versus try each, which was introduced in version 5 of the individual draft. Discuss the examples themselves, and then I've got a couple of proposals for new flow control primitives. Next, please.
So, Brandon, you want to generalize to something like software update manifest?
Maybe.
I mean, you're just looking for something that a search engine will find.
Yeah, exactly.
I like that name.
The problem with suit manifest is that you're not going to find it if you search for it. So, and to come back to the discussion that we were having previously with Kathleen's feedback, if we leave it as suit manifest, then it's quite clearly not for larger devices, right? Because it says IoT right in it.
Okay, so we're going with tuxedo manifest.
This is Dave. I like Russ's term. This is software update manifest sounds great to me.
Or he suggested tuxedo manifest, but
Software update manifest. Software update manifest was Russ's real suggestion, as opposed to the tongue-in-cheek one. Yes.
So the thing about run sequence was we originally introduced it to allow conditional processing, but it was a bit ambiguous on whether it was a soft fail or hard fail, and then it didn't have an else clause, which meant that if you went through and tested a number of sequences and they all failed, there was no way to catch that case in the manifest itself. So as a result of that, we introduced the try each construct. Now, the thing about that was that it's explicit that it's soft failure, even in its name, and it definitely has an else clause. So the question is, should we deprecate run sequence? Now, there's the possibility that we could use run sequence for another use case, which is specifically serialized out-of-order processing. The idea there is that you have several sequences, each of which need to be executed in order internally, but the order that you process the sequences in doesn't matter. That seems like a fairly advanced use case. So maybe it would be better to just deprecate run sequence and introduce a new extension. Next, please. So next, the example section is very big. Now, there are a few options that we have here. We can print some information because maybe they're a bit too verbose right now. For example, there was a JSON representation in the examples, and I'm not sure that we actually need the JSON representation since we also have the CBOR decode, CBOR debug info version of the information. We can move them to an appendix. In fact, we should move them to an appendix if we do nothing else. And the other option would be to move them to another document with more extensive use case information. Now, my inclination here is to move them to an appendix and prune the JSON representation. I'm not sure that moving them to another document is the best answer, but I'm not sure it's not the right answer.
All three chairs are agreeing with you.
Okay.
Meaning the first two options, please.
Okay, good. I'm glad we have some agreement. All right, next slide then. So the map test execute concept I was talking about. The idea here is that we have a fairly common set of patterns. So there's a for each component thing. So I have several components and I want to do the same thing to each of them. And then there's set a variety of component parameters. So set the digests for each of the components or set the size for each of the components. And then there's another one, which is choose a set of parameters based on some system properties. So that would involve essentially running the same sequence multiple times until you find one that matches. And then there's the prioritized parameter list, which is a generalization of the prioritized URI list that we've discussed previously. And that was a request from someone that I think that might have actually come from discussions with the TEEP working group, but I'm a little hazy on that one. And so the result of that was that I was looking for a catch-all approach. These all seem to share something fairly common. So what I'm going to propose is a map test execute structure. Now the idea here is that you first have a list of component ID parameter set pairs. So a set of parameters that gets applied to a particular component ID. Then after that, you have a test that makes sure that that set of parameters, or that each set of parameters is valid and aborts if it's not. And then an execute, which runs a command sequence that can't soft fail and wherein an error would cause command termination. Next, please. So there's an encoding there, and I should stress that the idea here is that there is exactly one test sequence and exactly one execute sequence. It's not one test sequence per parameter list. Next slide, please. So there's a trade-off here. So to make this work properly, there has to be a temporary set of parameters that is used before a test happens to prevent side effects in the system. So that does cost some RAM to implement. The benefit, though, is that it does produce a smaller encoding of repeated patterns. Now, I should make this clear. This is not something that's mandatory for the standard to work at all, but it is something that would produce smaller encoding under certain circumstances, and that's specifically where there's repeated patterns and parameter changes.
Brendan, this is Dave Woltemeyer. Just a quick clarifying question. Why do you need a set of temporary parameters to prevent side effects?
So if we go back a slide, or 2 slides like that, yeah. So you have this structure where you've got a map of parameter sets and then a test that happens after. Now you would anticipate that the parameter set will not be applied to your overall system state until after the test has succeeded. But because of the simplicity of the interpreter, you would have to apply the parameter set before running the test in order for that test sequence to have any effect, since it's going to work on the parameters that you've just set. So the temporaries are there to manage the state of those parameter sets until after the test has succeeded, at which point the temporaries would become committed. Does that make sense?
Yeah. My confusion was mostly around the terminology, I think. Yeah, thanks.
Oh, fair enough. Yeah, it's the terminology is maybe a bit still of a work in progress. So the question that I have is, should this be an extension? Should it be optional? Or should it be required under certain circumstances? Now, my recommendation is that if we use it at all, it should be required under these specific circumstances. If you have more than one component, it should be required. And if you have, if you're using something like AB offset or AB offset based execute in place images, then it should be required. Under other circumstances, so for single image devices with a single offset, then it would not be required at all. So that's my recommendation if we go ahead and use it. If we don't, then it could be added as an extension later on. So I'd like feedback from the working group on that, specifically on my recommendation to make it required for multi-component devices.
So I was just thinking on the question of should this be an extension or not. You know, are there anyone in the room that would implement this if this feature was provided? Anyone?
It's a compression algorithm, effectively, for compressing the manifest itself.
Sure.
I have on the thing that I sent to the list, I did show what it would do in a variety of circumstances. So I don't know if that's helpful or not in evaluating it. And maybe this is something that people need to look at a bit more before they decide on it.
Yeah, fair enough.
Okay, well, in the absence of any commentary on that, let's move on. So the other option would be for each component. It's a bit easier to understand, but it's much less flexible than the map test execute construct, and it implements only the for each component in a list do something structure, rather than all four of those examples that I provided earlier. It expands on the previous concept of using true as a catch-all. So this would allow you to say, you know, I want to apply a given sequence to all but one of my components, whereas the previous encoding didn't have any construct that would allow you to do that. So either map test execute or for each component would allow you to do this kind of construct, but the for each component one certainly is a bit simpler. And I think that's the last one. Oh, no, it isn't. There's a roadmap. Okay. Yes, so we have a fairly stable document already, but we want to make sure that it is just ready to go before the hackathon in February. And we're planning to have code and tools developed as input for that event. So we've already got those in development, so it's just a matter of getting them ready for release. And we're hoping to start a working group last call in March. I think that's it.
Go ahead, Hank.
Hi, this is Hank. Hi, Brendan.
Hi, Hank.
I have one comment on getting things smaller. I'm somehow involved in creating a lot of CBOR data items in the last years, and some of them unfortunately still have text values. This cannot always be avoided. I saw a bunch of new text values there. So we are considering in general to give a LZ4 compression to a data item. And as you are concerned with size, I just wanted to pitch that here. I don't think if it's useful or should be scrapped after uttering it. It's just the combination of ZBOR and LZ4 was also used for the DNS aggregation benchmarking thingy from the ICANN guys, and they were kind of fond of it because it reduced their amount of data significantly depending on firmware size. I'm not sure how much entropy is in there. It might not matter. But this is my first comment, just to as a food for thought.
So,
okay, before we go too much further, can I
Yeah.
recommend not LZ4?
Sure. Or any other appropriate other thing. Sorry.
Okay. The reason that I recommend against LZ4 is that it has a 64K table size.
Oh, shoot, forget it. Yeah. Good.
A bit painful.
Good argument. Thank you. I will keep that in mind. Okay, second item.
One comment on your comment, Hank. I mean, one
Sure.
of the things that we need to think about, though, if we're going to look at any kind of compression on these data elements, is sort of the size reduction versus processing cost, trade-off. Because we also
was
care
just
about
something
processing
I
cost.
had in the mind to ask everywhere. So I'm okay with that.
Yeah.
No, don't do it as totally fine. I'm not married to any of this. More of interest to me right now is the second question I have. In SECOM, we just had an interesting input from Kathleen Moriarty, because the CoSWIT CBOR data structure, that is also an optional item of the suit manifest, was proposed, there was a proposal from Kathleen to make that a CWT structure instead of a CoSWIT structure. The argument here was it would ease adoption of the data structure. As the suit manifest basically has the same data structure as the CoSWIT CBOR item, I would like to ask this group, would you see any obstacles in having a specific suit manifest tag instead of a CWT tag in front of the manifest map? And if so, is that a realistic threshold, or is this just a felt problem? I don't know. I really don't know, because I would think that if you make anything that is a CBOR map a CWT, you always inherit all the CWT normative language, which also includes, for example, the inclusion of all the 7 claims. And these have nothing to do with suit manifests, and for example, they have nothing to do with a CoSWIT software identity tag. And so my question is, would you be pro or con tagging this suit manifest with a CWT tag for the sake of bigger adoption in the field? Because CWT parsers are everywhere. This is the argument. I'm just reflecting the argument, and I see the same problem, applicable of this argument here, and this is why I'm highlighting it.
Personally, I am pro suit tag.
Do you think that the suit tag will...
And I would prefer a suit tag to a CWT tag.
And do you think that the suit tag will hinder adoption? Because it's not a CWT and they are less common.
I don't think it will, because I think the suit is a sufficiently specific use case that if I, for example, were updating or were designing a firmware update solution, it wouldn't matter to me whether it was a CWT or not.
Okay.
So I just wanted to point out that our charter is to create a suit manifest format, not to adapt, CWT to
this is the same is true for
problem space.
CoSWIT in SECAM, but still it came up there. And is this here the exact same semantic structure? I thought I would ask the same question here. Yeah, sure.
This is Hannes. So what happens if you just take the CWT but not the mandatory fields in there? Would that still be then okay? Because then the difference is maybe minor. Because some of the, from the top of my head, I don't remember what are the mandatory fields, to be honest.
Issue, subject, issue at best before ID, those things. And I think the issue is a non-issue here. So putting them in is kind of messing up the semantic,
So I think we're going to have to take this to the list because we're out of time for this
But
topic.
This seems to be a general question, and then we really need to have an answer for this, because it is,
So if you could post something to the list, that would be great. Brendan, any last word before we wrap up?
No, I think that's it for me. Well, I guess the only thing was to respond to one other thing that Hank said, which was that we're adding a bunch of text fields, and I would note that those text fields take only the size of the digest to populate.
All right, great. So now we're going to move on to the other work phase. I'd like to have Dave Thaler talk about manifest requirements from the TEEP working group, and then we have one other presentation. So you have 10 minutes.
Okay, I'm going to try to be fast, and I hope Brendan stays at the mic here. As you may know, the TEEP working group about an IETF meeting or so ago decided to take a dependency on the suit manifest, or the software update manifest. If you're not familiar, TEEP provisions code and configuration into a trusted execution environment. Brendan presented the suit manifest to the TEEP working group at an interim meeting, and As a result of that, the TEEP working group has gone through to compose what is the requirements of the suit manifest that it may or may not already meet, and this is the list of stuff that came up in the TEEP meeting. And we wanted to walk through these briefly and get a yep, that's already in there, or nope, we got to do something to add that. Okay, so I'm going to walk through these briefly, and this is really the only slide that I want to walk through unless you have questions, but otherwise this is my only slide, right? And so let me just prefix this by saying Brendan showed a bunch of use case templates, and so you might think about should we want a use case template for any of this stuff is an interesting question. So let me walk through these things, because earlier in this meeting we said, hey, the suit manifest or software update manifest could be usable for larger class things, updating Linux, updating Windows or whatever, but hey, has anybody gone through to validate that that would actually work? Well, that's the exercise that TEEP just did for a trusted execution environment. It says, would it actually work? And this is the list that we came up with in the TEEP meeting. And so I'm going to walk through each of these, and hopefully we can say this is already there, or it's not already there, but it could be easily added. Okay, so here's the 4 things. The first one is to say for any dependency from a particular item that needs to be installed, a thing that has a manifest, any dependency, the ability to list one or more URIs, and those are not URIs where the binary can be downloaded. These are binaries for which you can use a protocol to negotiate the security mechanism needed to, say, get the decryption key or whatever else, okay? And so could we have a URI associated with a dependency that's not the URI for the binary itself? That's number 1.
Yes, we could. We don't currently have that, but
okay.
it's an easy add.
Thank you, because that's the main thing, is each of these, yes, it's already there, or it's an easy add, or it's a hard add, and so thank you, easy add, okay. Hank, did you have a comment on that one?
Not anymore.
I'm trying to stay in 10 minutes. Okay, number 2, on certain types of TEEs, there is, in order to install the binary, you have to do a particular thing that's to create this security domain concept. So you'd need some type of a command or directive or whatever that says, create me a security domain if it doesn't already exist, and here's the ID of that thing. And there would just need to be a way to express that in the manifest.
That should be doable.
Already?
I think that's already doable.
Okay.
If you need to do explicit create operations, that might be an easy add rather than an already doable.
Yeah, this is a create if it doesn't already exist, and test and create if it doesn't exist.
I think we already have that available.
Okay, and just the notion that the thing that you're trying to create, as long as there's some way to say the thing that you're trying to create is this security domain or some way to designate, that's what it means when going into this particular place on the device.
Yeah, I'd like to talk with you a little bit more offline on
Okay.
that, but I think
Fair enough.
we already have that, and if not, it's an easy add.
Okay, great. Okay. Number 3, and I'm pretty sure this one isn't already there because Brendan presented this at the intro meeting, but since it came up in TEEP, we said the ability to update a file that is not a binary executable.
Definitely have.
Right, that was my understanding.
Yeah, also, this is why I'm here. This is where the CoSWIT extension and the suit manifest kicks in, basically. If the manifest itself is somehow lacking some semantics there, I think it all can be added on by the root CoSWIT extension.
Yeah, so my personal belief was this is already there, and Brendan talked about this at the intro meeting, and I just wanted to confirm. Okay. And then the last one is if a device has multiple trusted execution environments, say it has, SGX, a TPM, and whatever else attached or whatever, then you can indicate which one of those hardware places is where this binary should be installed to.
So this is the exact intent of the component ID.
Yep.
Yeah.
As long as each of these can be identified by a component ID, that's the whole point of it.
Yeah, so it's really, is the component ID sufficient to do that? And hopefully the answer is yes, but we need to actually test that. These are all things that if we think the answer is yes, we could actually use the hackathon to actually verify that, the February hackathon. Okay, that's the list.
ID should be what you use there.
Okay, so this is my,
That's the whole point of it.
okay, great. So it looks like we have maybe 2 easy adds and 2 things that should already be possible. We just have to confirm that it works great in an implementation. Thank you, that's my report out from the TEEP working group. sounds like we can use it just fine, and we should think about, Brendan, should think about, would it make sense to add a use case template for a TEEP use case or not? How do we want to do that in a document? Okay, all right.
Yeah, I'd love to do that.
All right, great. That's the end of my presentation.
Good afternoon, everyone. My name is Soyeon Choi, and I'm studying in Sangmin University. And this is my third time participating in IETF, and this is my first time giving a presentation in IETF. So my whole body parts are so shivering right now, but it's so honored to stand here. And this is my first step of my work, so any comments or feedbacks, it would be so grateful. So today, I'd like to discuss about a distributed suit architecture model. And the contents of today's slide would be traditional suit architecture, proposal, and next step. So let's see the traditional suit architecture first, then let me explain my proposal, then my next steps. So the traditional suit architecture is adopting client-server model. So apparently, manifests and firmware images are downloaded from firmware servers. So the picture on the right side of my slide is exactly from the architecture draft of suit. And there's a server between author and firmware consumer. But that client-server model, which has centralized architecture, can cause overhead on servers, and that overhead occur update failures. And also, servers can be targeted because of that centralized management and other authority, so it can be targeted by an attacker for use in an attack. And plus, we'd like to define a new issue called author disappearing issue, which is literally happens when an author's disappeared. So if authors disappeared, firmware consumers who have not yet updated to the latest version cannot catch up. So let me illustrate the author disappearing issue more specifically with a scenario. So maintenance of servers is dependent on the author's management. Like, for example, for a short period or a long period, authors could be disappeared because of a bankrupt or an attack by an attacker. And for that period, they cannot manage their servers, and servers would be gone after that. So if servers are unavailable, of course, the data are unavailable too. So in that case, when firmware version 4.0 is uploaded by an author, then status tracker give a notice to a consumer that they have to get updates, and after that, in case of firmware version 4, it can be updated completely. But in case of firmware version 5, if author disappeared after they uploaded, consumers cannot download the tuxedo manifests or firmware images from the servers because servers would be gone, so they cannot get the files. So to sum up the shortcomings of current suit architecture, because it's adopting traditional client-server model, it cannot deal with an author disappearing issue. And I'm suggesting that blockchain can solve the shortcomings because it provides distributed storage for manifests and firmware image files, and it provides irreversibility for manifests and firmware image files, which means this data stored on blockchain are not going to be erased or changed. So in case of blockchains applied on the architecture, when firmware version 5 is uploaded by an author and on the blockchain, and even if after authors disappeared, the consumers can still download that files because blockchain is still going to store that data even after the authors disappeared. So my proposed architecture is just like this, and firmware server in original architecture it'd be changed to blockchain, and it's gonna have distributed storage, and data is going to be irreversible, and it's going to provide high availability and high reliability. And to solve bottleneck problem can be occurred in blockchain network, we decided to have registration nodes and retrieval nodes. And registration nodes are which process the node registrations based on IP. So when authors want to upload their firmware images or manifest files on the blockchain, registration nodes will register the files based on URI's IP. And retrieval nodes are going to retrieve the IP or URI when firmware consumers want to download the files. So there are public-private consortium platforms in blockchain, and private because of public blockchain platforms as the aspect of public blockchain platform is that everyone is open to read or write data, so there's a high risk of attack. So private or consortium platforms would be better to use in this architecture. So for large companies producing IoT devices, yes, yeah.
I have a question, but I'll gladly defer to Brendan first.
Yeah. Oh, this one, this page.
Okay.
Sorry, I was actually
Okay.
going to wait till the end. That's
Okay.
Keep
All
going.
Okay. So for large companies producing IoT devices, it'd be better to have private blockchain platform because because they have much power than other small companies, so it'd be better to have their own system to manage them. And small, medium enterprises with higher possibility of author disappearing issues, it's better to have consortium blockchain platform because even if they have author disappear issue, the nodes connected to that enterprise could be connected to other enterprises that manage together. So yeah, these are two architectures that can be adopted. So the question was?
Yeah, so my question is, this is Dave Waltermeyer. My question's on this model. So earlier when you were presenting, I was wondering, who's going to host this blockchain?
Yeah.
So for large companies, are you envisioning that would be used in a case where different parties were authoring software for the devices that those large companies are producing? Or would the large company be the author? Because if the use case is to protect against the author disappearing, if they're hosting their own blockchain, it'll probably disappear, right?
Yeah, actually the nodes constituting the blockchain, it'd be not only authors, but it'd be participants who want to be that nodes of the blockchain. So there should be a list management of author, but normal participants, users going to have that data too because they're going to be the users, normal users, yeah.
And that's much clearer in the consortium case where, a bunch of authors and consumers can band together and host the necessary nodes. That's the idea there, right?
Yeah.
Yeah, okay.
Brendan, are you next?
Is it me? Okay. So can you go back to slide 5, please?
Slide 5.
Yeah.
Okay.
Okay, so I'm a little unclear on what's happened after the authors disappeared. Why is the server, the firmware server, no longer responding?
Because the disappearance point of firmware server would be immediate or a few days after, but the point is that servers should be managed by an author and like.
So the idea here is that the server is manufactured by the author, or is managed by the author?
Yeah, like they have to pay for the cost of managing them, or.
Okay.
Yeah.
So Soup was designed for use with content distribution networks, specifically untrusted content distribution networks.
Yes.
And that was the intent from the very beginning.
Yes.
Would you say that a blockchain would constitute an untrusted content distribution network?
Yes, because blockchain works under based under blockchain works based promised rules, and just like servers get certificated data, just same things happen in blockchain, because nodes are gonna nodes are gonna give consensus on only data that have authorized with certificate.
So then it sounds to me like the existing suit architecture actually already is compatible with us.
Because
if we say that blockchain is an untrusted content distribution network, which we just did, then I would say that since suit is designed to work with untrusted content distribution networks, we're already there. We're good.
If there is efficiency of explaining the beneficials of blockchain, then I think I have to explain it more specifically by mailing list.
So
Brendan's
I'm observing
point,
we have 3 minutes left and 3 people at the mic line, and so.
Okay.
Brendan's point is that he thinks that the blockchain can simply be a URL like any other URL. That's his point.
Yeah, you mean, yeah. The blockchain's gonna store the manifest files, and manifest files are stored distributedly, and URI is gonna contain in that manifest file. Yeah, but yeah, still blockchain can give integrity and irreversibility for the datas.
Okay, let's go through the rest of the mic line. Please keep your comment short because we only have a couple minutes left. But let's go ahead.
Michael Richardson. So I like this. I like the concept that the firmware is distributed independently of the authors, and there's a number of groups. The Secure Home Gateway project at Sierra Labs actually wanted to have exactly that. We wanted to collect all of the firmware from all of the devices that we've ever seen, specifically for the author disappearing case, and you didn't update the latest thing before they went away. And so this is really interesting, and I think that a little bit I have very pessimistic views of blockchain, but the one advantage is that stuff is hard to delete from it. And so
Yes.
you can't take things back because you didn't mean to release that version that get people whatever. So I think that's a really interesting thing. I do have some questions as to what the incentives to verify the blockchain for the various participants are. I think in the SHG case, we would be quite interested in verifying the blockchain for free. Okay, maybe others would need an incentive. But I think that's why my major usually problem with blockchain is why would I care, right? And so I think in this case there's some value. And finally, I think it's reasonable that quite a number of entities, hospitals for instance, will be quite willing to run the server, a couple of devices inside that have external connectivity to talk to the rest of the blockchain, but also have internal connectivity to track to a whole bunch of devices which they otherwise don't let out on the internet. And so I think that's a useful thing, and it's just a distributed cache. That's cool.
Thank you.
So we're officially out of time, but we can take, like, if these are very short comments, we'll take them now.
I'll go fast. First of all, you're doing a great job for your first IETF presentations. You don't need to be nervous.
Indeed.
I want to agree with what Brendan and Michael said. So this kind of thing's been done before. This reminds me of like distributed file systems over blockchain, like interplanetary file system, stuff like that. It's currently in use for stuff just like this, for maintaining immutable files on a distributed file system. Using it for suit is cool, and there are some use cases where you could actually do that. I don't think that we would need to make any changes to suit to support this.
Yeah.
I think that you could just take suit and just distribute it over a distributed file system like this, and you're good to go. So I don't think you need to make any changes here, but it's an interesting project.
Thank you.
Hi, this is Hannes. I was wondering about one thing which you may not have addressed yet, is if the author disappears, the other problem is what happens with the keys, because the manifest needs to be verified. So there also has the private key, and unless he makes that available to someone else, you're not going to get any updates in the future anymore, which could be a problem.
Yeah, I think
But Brent maybe has the answer.
that should be more discussed myself.
So I think we're going to have to take this
minutes.
offline. Are you available afterwards to answer any questions?
Oh, yeah,
'Cause-
sure,
Okay,
sure,
great.
yeah, thank you.
So I think with that, we'll have to, to close the working group meeting. Thank you. We'll see you next time in Madrid. If you haven't